All right, hey y'all, my name is Vicki. I'm a PhD student under Bill Walton, but today I'm actually not going to talk to you about Alabama. I'm going to talk to you about North Carolina. I was able to do some of my resubmersion work here in North Carolina, so I'm excited to share that with you. Now, as y'all all know, farmers will routinely handle their oysters in order to create a pretty product. These oysters are removed from the water for things like desiccating or air drying, tumbling through a mechanical grater, and sorting and grading by hand. Now, all of these things are done to prevent biofouling like barnacles, mudworms, and to create that beautiful deep-kept oyster that will give you a higher profit on that half-shell market. But during these routine handling processes, those oysters are removed from the water for extended periods of time, and that creates an increased human health risk in regard to the Vibrio bacteria that are found in the oysters. So for those of you that don't know, Vibrio are pathogenic bacteria. They are naturally found in the waters where you grow your oysters, so there's nothing you can do about that. But they are important as a public health risk. There are two species that are important. The first is Vibrio vulnificus, or what I call VV. This species causes wound infections as well as acute septicemia, and it's important because it has the highest case fatality rate of any foodborne pathogen out there. The second species is Vibrio Parahaemolyticus, or VP. This species is important because it causes gastroenteritis as well as wound infections, and it is the leading cause of seafood-related infection in our country. So now that I've scared you all, I'm going to tell you how farmers can help to mitigate that risk. So when those oysters are removed from the water for routine handling, they are exposed to higher temperatures outside of the water, as well as they are closed. They are not filter feeding. And this basically creates the perfect little incubator for Vibrio bacteria. So while they are out of the water, those Vibrio levels will increase within the oyster. But as farmers, y'all have this unique option to put them back in the water. And this is what the regulators will call resubmersion. So when you put them back in the water, those oysters will open up again, they'll begin filter feeding, and those elevated levels of bacteria are purged from that oyster. Now, we say that they will return back to ambient levels. Those are the natural levels of Vibrio within the oysters where you are growing them. Now, after waiting that appropriate resubmersion time, the farmer can go back out, harvest their oysters within that appropriate time temperature window, and sell them on the half-shell market. So previously in North Carolina, there actually was not a resubmersion requirement until recently. I talked to Shannon Jenkins, who is the Shellfish Control Authority person in the state, and he said that it was recently updated to require a 14-day resubmersion period for any exposure greater than 5 hours. And this is between the dates of May 1st and October 14th. But a lot can happen in 14 days, especially down south. We found that things like mudworms can reinfest your oysters within 14 days. So some of my previous work, as well as a previous graduate student, have found that a 7-day resubmersion period is sufficient for a whole host of different handling treatment combinations on the adjustable longline system. So we wanted to know, does this 7-day resubmersion period have a wider applicability to other states as well? So ultimately, we wanted to know what was the appropriate resubmersion period for North Carolina. And in order to do this, we wanted to look at this for different handling types. So I was fortunate enough to be able to come out here for 2 summers. I worked with Jay Styron of Carolina Mariculture, and his farm is located in Cedar Island. I performed 4 trials during the summers of 2018 and 2019, and we used the floating oyster grow cage system. The reason why we used this system was because this study was designed as a sister study to Alabama. We did a similar study in Grand Bay, and the oyster grow system was a common gear type between the 2 areas. So for this study, we wanted to look at 2 different types of handling. The first is tumbling. A lot of farmers will tumble their oysters, and that is a rougher form of handling than simply air drying those oysters. So when you tumble your oysters, will that affect how quickly they resume pumping once they are back in the water, or will it have no effect at all? Then we wanted to couple that tumbling with a potential overnight refrigeration treatment. So we know that refrigeration can help prevent Vibrio bacteria from growing within the oyster. And so could a farmer refrigerate his oysters overnight after handling them before putting back in the water? Would that help the resubmersion period? So for this study, we looked at 5 different treatments. The first is a submerse control treatment. These were oysters that never left the water, and that way we can know what the ambient levels of Vibrio are in the oysters over time. Then we had 4 different handling treatments. So we took all the oysters out of the water. Half of them were tumbled, and they were basically sent through a mechanical grater once. The other half were not tumbled, and they just stayed in their bags. From there, we took half of the tumbled and half of the not tumbled oysters and refrigerated them overnight. They were placed into a portable refrigeration unit for about 18 hours. The not refrigerated oysters remained outside in their bags. So this gave us 4 different handling combinations. We had a tumbled not refrigerated, which is basically a tumbled and desiccated treatment. We had a tumbled and refrigerated treatment, a not tumbled refrigerated treatment, which is basically oysters that were refrigerated, and then a not tumbled, not refrigerated treatment, which is a desiccated treatment. During each of these trials, we took samples at several different time points. That way we can track how those Vibrio levels changed over time. So before we did anything, we took pre-treatment samples to get a starting baseline of where the Vibrio levels started. Then we had our treatment period where we pulled those oysters out of the water, applied those treatments. Immediately after that, we took post-treatment samples, and then we put the oysters back in the water. From there, we had a 14-day resubmersion period, and so we collected samples at days 1, 3, 7, 10, and 14 days after being back in the water. Now, all of those samples were taken back to the lab and tested for 4 different Vibrio species. We had total Vibrio vulnificus, total Vibrio Parahaemolyticus, as well as the pathogenic VP strains. Now, I could go into all the details about how I processed the oysters and did all the statistics, but I will save you all of that. That way I can go ahead and show you the results. So all of my graphs are going to look the same, so I'll go ahead and explain it to you. On the horizontal axis, you see those 4 Vibrio types. On the vertical axis, you see log NPN per gram. That's just the bacterial level within the oyster. All of the green bars are the submerse control bars, or the submerse control treatments. The blue bars are the refrigerated treatments, and the orange bars are the desiccated treatments. So you see immediately after those handling treatments were applied, but before they went back into the water, we saw that significant increase in bacterial levels in all of the not refrigerated treatments. That's what's happening when you pull them out of the water. Now this is on a scale of magnitude of 1 to 2 logs increase in that bacterial level, whereas we did not see this increase in the refrigerated treatment. So that refrigeration was successful at preventing the Vibrio bacteria from growing. But after those oysters had been back in the water for a day, we actually saw that the refrigerated treatments had that significant increase in Vibrio levels. So refrigerating them overnight only delayed the increase by 1 day. We still see that the non-refrigerated treatments had elevated Vibrio levels as well. After 3 days back in the water, we start to see that some of those Vibrio levels are starting to recover back to ambient levels, especially the total VV levels, as well as some of the pathogenic VP levels. But we are still seeing elevated total VP levels in all of our treatments. And finally, after 7 days of resubmersion, we see that all of the Vibrio species and all of the handling types have recovered back to ambient levels. So just to sum this up, this is a table that kind of splits it out based on the Vibrio species as well as the different handling types that we tested. And you see that the resubmersion times ranged from 1 to 7 days, and total Vibrio Parahaemolyticus actually took the longest to recover. So in summary, rough handling did not seem to affect the resubmersion period at all, but we definitely did see a refrigeration effect, as refrigeration actually delayed that increase in Vibrio until after the oysters are resubmersed. So you need to be careful with that. You think refrigeration could be a good thing, but it is delaying it. With that being said, there was no added benefit to refrigerating your oysters while out of the water. So it's not necessarily something that you should start doing, because regardless of that, the Vibrio recovered after 7 days of resubmersion, regardless of the handling type used. So hopefully this data can help your Shellfish Control Authority make a better informed decision. And with that, I would like to thank all of the people in Alabama who've helped me along the way, as well as the awesome people here in North Carolina who helped me, especially Carolina Mariculture, Jay and his dad Farmer, as well as Joe, who helped me out a little bit. And the folks at the Noble Lab at the UNC Institute of Marine Sciences, who graciously opened their doors and let me invade for 2 summers. So I can take any questions.
Thank you. Any questions for Vicki? And does anybody know where the other microphone is?
Oh, it's right here.
Oh, thank you. Any questions for Vicki? While I'm walking her over, the only thing she skipped on the methods, and I understand. I know why; those are hard. But they are using the FDA-approved methods. So the data she has generated is exactly what the control authority is already using for their standards. It should be a one-to-one match with what.
And a note on that: so this data can be requested by your Shellfish Control Authority once it has undergone internal review. And in fact, your Shellfish Control Authority has been emailing me about this, so as soon as it is ready, I will let him know.
Yeah, one of the processes we use is flipping cages and having the oyster grows in the air. Is there a length of time that you notice that the Vibrio takes, is it extended, the life of the Vibrio, whether you have the cages for up in the air for 12 hours versus 24 hours?
So in this experiment, we had them out of the water for 24 hours, which was like the worst case scenario, because I don't think anybody would desiccate for more than 24 hours. And so what you're seeing is kind of like the most abuse you would ever put on an oyster. So anything less than that, I don't have data on that, but I would assume that the bacteria wouldn't have as much time to grow with less time out of the water.
Very nice work, Vicki.
Thanks,
So
Andy.
in Alabama,